time to experience something glorious. Unacademy combat. Compete, crack, conquer.
A challenging gate contest engineered to give you an experience like none other, where you put your knowledge to test
and battle it out with a test.
to bring out the best in you. Unacademy Combat is the most competitive, gamified contest for gate till date, with the best of the questions by best educators.
with detailed video solutions from top educators right after each contest.
Combat live with peers to get real-time rankings and win big.
Participate in every contest to improve your ratings.
Challenging contests every fortnight or alternate Sunday. Live ranking after every question. Big rewards for top rankers. Your passion to crack gate deserves this. Your hard work towards your dream deserves this. Fuel your inner fire for the ultimate gate challenge. Unacademy Combat. Register now.
Hello friends, welcome to Unacademy, which is the largest online education platform for GATE, CS and IT. Myself, Mallesham Devasane. I'm taking the classes for Discrete Mathematics and Theory of Computation, Compiler, also C Programming. In this session, we'll be seeing very important session, that is propositional logic and predicate logic. This is a first order logic we are going to discuss. And if you look at the previous year GATE questions, every year at least 2 questions are there from this topic. Average 3 to 4 marks will be asked only from this topic. So propositional and predicate logic and also propositional logic may appear in general aptitude too. So if you want to prove some kind of deductions, inference logic is used even in general aptitude. So assume you might have minimum 3 to 4 marks in the exam if you can practice the propositional logic and predicate logic. And the important topics are here like equivalences, inference logic, and identifying the predicate logic for the given English statement. So these are the things could be possible in the exam. Yeah. Arnab, good morning. Aishi, good morning. Jyoti, good morning. Yeah, Lavjit, good morning. Jashkaran, good morning. Saurav, good morning. Yeah, good morning, guys. Okay, we are on the 3rd day of Discrete Mathematics. Then tomorrow onwards we'll start the graph theory, right? So let me complete today propositional and predicate logic. My main focus is on, as I said, two things I will focus. I will describe all the important definitions. Once I represent them, then I will go for inference logic and then writing predicate logic or first order logic for the given English statement. These two are mainly focused on this today's session. Okay, in case if you want to know about profile, that I am an expert in TOC CD and C, DS and Algo and discrete mathematics and little bit in operating system, where if you want to attend my classes, you can visit unacademy.com/DEVAGATE CSE. This is my profile link, unacademy.com/DEVAGATE CSE. So visit this profile link, visit my profile to watch all my free classes. Also follow the educators where you can enjoy a lot. This is my URL, and also I have a referral code in case if you want to take the subscription or you want to attend a free classes on Unacademy, then you may use my referral code to unlock the free plan on Unacademy. We have started the new batch from 18th Jan for GATE 2022. If you are preparing for GATE 22 and this is the right time to start your preparation, so you may use code to get 10% discount DEVALIVE. And here the mainly RBR is going to take the many subjects, and as you know that you have 12 subjects, so you must start early in your preparation. So start as early as possible, and in Sankal batch we have planned to complete entire syllabus by 29th, but it goes till I think 31st. By 31 I am going to complete the discrete mathematics, and before that almost all subjects will be covered on this platform. And if you are not aware of using Unacademy Learning app on your mobile, so go to Play Store and install Unacademy Learning app, and you can watch all free classes using your mobile, and also you can take the subscription if you require. If you have two kinds of plans on Unacademy, Plus and Iconic, where Plus you have live classes and structured courses and batch wise announcements. Every month 1 or 2 batches will be announced, and you can join all the batches or you can follow one batch to prepare effectively. So here you have a problem. In Plus you have unlimited content where you can watch anything in any number of times. So Plus you might have a problem that you need support from somebody. So Iconic, that will overcome. You will have a coach to help you how to prepare systematically with a particular plan, and that study planner is not there in the Plus. You need to plan as per the batch announcement. We are going to cover the 12 subjects as per the planned by the educator, but for you, and if you have missed any subject, and you have to plan according to your requirement. And Iconic, we are there to help you, and we have a coach assigned to you. He will helping you all the time to prepare effectively, and also you will have one-to-one interaction with educators in Iconic plan. So preparation, separate study material and separate sessions to boost your preparation, and many benefits in Iconic. If you want to know the prices, Plus if you look at 1.5, 2 years, also you have 1 month, 3 months, 6 months, but they will be useful only when you have less time. But now you have more than 1 year of time, so better to choose the either 1 year or 2 years plans. If you go for 2 year, you have 39,600 after applying referral code DEVALIVE. Similarly, you have Iconic. In Iconic, you have 66,600 for 2 years. And also there is a placement batch starting on from yesterday. It was started already. So you can join this placement batch along with the GATE. So there is a combined plan for that. That's called as combo subscription. And on Plus you can go for 1 year, which will be 51,233, which includes a GATE as well as competitive program. So you may use the referral code to see that total price 51,233. right? You also have flexible plans, then you can choose as per your requirement. Yeah. So this placement batch is associated with Code Chef, so you will be enjoying a lot because you have top educators in this placement batch, so you can follow them. All these educators are going to give you guidance in preparing for placements as per the planning. Yeah, good morning Simon, good morning. Oh, Jaskaran, great. Yes, Arnab will come soon. Right now it is A, right? Most probably next month it will be announced. Arnab. Sarvesh, good morning. Oh, Vaishnavi, I do not know what was the problem. Yeah, Rutika, good morning. Yeah, good morning, guys. In previous session, I know what I have covered, so I tried to cover the set theory in last 2 days, like sets, relations, functions, group theory, and lattice theory. Yeah. And now we will move to propositional predicate. I know that in the set theory there is a lot to learn. In Sankalp batch we are trying to cover what is the best for you, but there is a lot to learn if you want to learn the actual subject. So based on the time, and you have the exam in the next month, so we have planned a practice and preparation, all the things. And not only practice, you are also learning in this Sankalp batch. So I'm going to promise one more thing, that is you will have a lot of practice sessions, but you just wait for a few days till end of this month. You will be having many practice sessions on many subjects I'm talking about. Yeah, I will do that, Ayushi. Yeah, today I will do, definitely. I'll send the PDF in Telegram group. Yeah, thank you, Jaskaran. Rank 1, yeah, great, Jaskaran. Yeah, congratulations. Yeah, great. Yeah, today's session I'll be planning for propositional and first order, call it as a predicate logic. Fine. Now let's begin. Good morning, Ashish. Propositional logic, and these two are part of the mathematical logic. You can call it as mathematical logic. As a programmer, as computer science student, we must be good at this topic. Why? Because most of the programs, their logic is represented using predicates and propositions. And if you want to join in testing and verification in future, somebody written the program, you want to verify using tools or using codes, then you must be good at the propositions and predicates. This will help you to implement the tools to verify the programs with propositions and predicates, because basically your program will be converted to the set of propositions and predicates. So in that sense, the mathematical logic is going to play important role for the programmers, but theoretical programs I'm talking about. So you want to verify theoretically or even sometimes practically, you can implement a tool with the help of the propositions and predicates. Okay. Now in this propositional logic, I will quickly try to cover all these important points, but I will mainly focus on inference logic at the end, if possible. And propositional statement, first, what is it? And you need connectives, and you have so many important words like satisfiable, falsifiable, tautology, contradiction, and contingency. And then we will go for inference logic, and so many equivalences, logical equivalences, that I will be talking about here itself. Okay. So let's start with a propositional statement. What is the propositional statement? It is a statement where its truth value is either true or false. Example, if I want to talk about, I want to say something like that. Today is Monday. It's just a statement. If today is not Monday, you say false. If today is Monday, you say true. Only true or false, two truth values are there. Yes or no? And most of the times you can always interpret this propositional logic is similar to the Boolean logic. In the Boolean logic is we have same true or false or 0 or 1 in digital logic. Boolean logic, digital logic and propositional logic all will be, looks similar. Yeah. Here we are going to see a propositional variables, like the statements I may convert today is Monday to either M or T, whatever, M. So I can convert these statements into a variables. And here two types of statements. One is atomic statement, where you do not have any connectives, simply a variable is enough to represent atomic statement. But there is a complex or compound statement. You can say complex or compound, where you want to connect two propositional statements using connectives, then you can say that it is a complex statement. It requires the support of atomic statements, also requires the support of connectives. Yeah, good morning Kuldev. Clear this point? So atomic statement where it can be simply represented with a variable without any connective. It's a very simple statement. You can say simple. But complex statement is like a compound. You require connective support to write the complex statement. Like today is Monday and I want to watch a movie. So if I want to say that, then I need two things. Like today is Monday and let's say I will write exam or I write exam. So present, past, future sentence, please avoid them. We don't need here I will write or I am writing or I have written, all such things we don't care here. Okay. So just here let's say I write exam. So now and is called as a connective. This is called as complex statement where you require the support of atomic statements as well as connectives. Everybody, so this is called as a proposition. The proposition can be atomic or can be complex. If it is complex, you require the connective support to represent a propositional statement. And this propositional statements also called as propositional formulas. Okay, let's look at what are the connectives you have. Yeah, Satyajit, good morning. What are the connectives you have to represent a propositional formula or propositional statement? Okay, conjunction you can represent as, you can call it as and if you want. And disjunction you can call it as or operator. And negation you can call that operator name is not. And implication actually you should call conditional. That's the implication. It is actually called as conditional. And by implication you will have this operator and it's also called as biconditional. And true or false are other than the variables. If you want to use true or false, you can always use as the connectives. They are not variables. So when you are dealing with propositions, when you are dealing with any propositional formula or any propositional statement, you will have a variable sometimes. You will have either true or false. You can use true or false inside proposition as a connective if you want, and you will have the operators, that connectives. Even true or false are kind of connectives here. Yeah. Everybody, every proposition you may use variable, true or false or connective, and together will form a propositional statement because its truth value is either true or false. Now let me talk about each one of the connectives. Okay. Let me talk about first conjunction. Of course you might know it, right? So can I keep all of them together? Can I keep all of them together? Okay, except not. Okay, I'm just using two variables, let's say PQ. This is for conjunction, disjunction, implication, and then by implication. And not you can apply to any variable separately. Yeah. See here, I am using P and Q, and P or Q. P implies Q. P is a by implication with a Q. No, Kuldeep, it's just a symbol, it's not a function. P implies Q is not a function. Okay, so we have 4 possible combinations. Good morning, Gaurav. And what is this called as? We have interpretations. Here we are doing 4 interpretations or 4 instances and 4 possible solutions. Are you clear what I am saying? 4 possible substitutions. But look at what will be the truth value of the each connective. And when you apply conjunction, the true happens only when both P and Q are true and remaining all false. Remaining all false. Yes or no? And P or Q, if both are false, then only false, remaining all are true. Look at what I am trying to help you. In the disjunction, the false will happen when both are false. In remaining all the cases, it will be true. And P implies Q. Whenever P is true, Q has to be true. In case if Q is false, the result is false. But remaining all the cases, somehow it is true. And P is true, Q is false, then P implies Q is the false. And PQ by implication, if both are same, that is P and Q are true or P and Q are false, then by implication will produce or will interpret as the true. And remaining cases, it will interpret as the false. Everybody? So interpretation is very, very important. Okay? And mainly look at the different behavior that you have. That is very, very important in this. Remaining all are very easily you can understand. I hope everybody knows these definitions. And P and not P will be very easy. If you want to apply negation, can be applied only for one variable, that is unary operator. That is unary operator. If this is a true, we will say false. If it is false, we will say true. This is about unary operator. Yeah. So I hope you don't have much problem in this, right? That's why I just given one table. But understanding these things, statements are little bit tricky. Look at conjunction. You know it is P and Q, but will be asked P and Q. When somebody is saying P and Q, you might be given in English language P and Q. P is a statement, Q is a statement, they will use and Q. Or sometimes P but Q. It also gets the same meaning. It also gets same meaning. today is Monday, but I will go to movie. That means I am saying today is Monday and I will go to movie. Clear? So in all these three situations, you must say P and Q. P and Q. Clear? So conjunction you must use even though but word comes in the English line. Okay, now let's go to implication. There's a conditional. Conditional. We know P implies Q is a conditional, but you can apply converse, inverse and contrapositive of that implication to get the new meaning. So converse of P implies Q is the Q implies P. This is the converse. Suppose if I say if today is Monday, then I will go to movie. Then converse of the statement is if I will go to movie, then today is Monday. So it will change the statement. Everybody? So you have to, they may ask you in the exam which is the converse of the given statement. Right? Yeah. And inverse of P implies Q is the negation P implies negation Q. There is not P implies not Q. And contrapositive of P implies Q is the not Q implies not P. And three things you can apply if you want to apply for any statement like if today is Monday, I will write exam or I will attempt the test. So here I can simplify today is Monday as let's say P and I will write exam as a Q. Then now you can interpret as per the given statement. You know, if I ask converse, what do you get here? If I write exam, then today is Monday. Inverse is not P implies not Q. If today is not Monday, because not P, then not Q means then I will not write exam. Then I will not write exam. Okay, last one, contrapositive. If today is Monday, I will write an exam, that is then is there, comma represent here, then is there. Okay, not Q means if I will not write exam. If I will not write exam, if I don't write an exam, you can use present also. If I don't write an exam, then today is not Monday. Yeah. Yeah, Kuldeep. Yeah, I went to research and I know, when, what kind of problem that I have faced that you do not know, right? Of course, I am interested in research, but not like this. And teaching is the one profession where you can share to the maximum people what you have. So I felt, why can't we choose the teaching field, right? It's just, perception that even you wanted to do the agriculture, you can go for that, right? So research is your option, my option is the teaching. But of course, that if I change my mind, I can also go for the research. It all perception based on situations. The people chooses their life, but some people are committed, some people are determined, and they choose whatever the cost happens. But for me, I tried in many angles, but I went to research. I took the break. I joined in PhD, right, at ISE Bangalore. But after 2 years of the time, then because of so many problems, maybe either financial or maybe personal problems or many situations, I had to come out of that research. Now today I am in teaching because of I also did the research before this. Yeah. Everyone, so, yeah, you have to choose the life based on the circumstances that demands, and sometimes we can't force the situations. Yeah. Okay, next one, conditional and biconditional. Look at this conditional. Conditional, you know, of course here PQ is there, I can't say that. P if Q is actually here there are two statements, P only if Q. Out of these two, who is P implies Q? P implies Q happens here. P only if Q, and another one P if Q means this is Q implies P. So you should be very careful when you are dealing with two words. If only if are two different statements. Everybody look at here, if and only if. Here only if also there, here if also there. P if and only if, actually you are trying to talk in both directions. Only if will talk about this direction, if will talk about this direction. Are you understanding if and only if means? If actually speaks in right to left. If anybody writing, okay, let me tell you. If you have P implies Q, you know that it is if P then Q. You know that. And you know that P actually is Q. And you know that P implies Q. These all are the representation of P implies Q. Now I can speak the P implies Q some other way. How? Anybody? That is what? Using if and only if. If I want to use only if, I can use like this. P only if Q. That's right. It is another way to use the same statement. And if you want to use the same thing, you can speak another way. Q if P. This is also right. So this P implies Q. You can say P is Q. You can say if P then Q. You can say P implies Q. You can say P only if Q. You can say Q if P. All are just saying that P implies Q. Are you clear? So you should be very careful when you are using if and only if. Because people can speak any of these two words in English line. If they are using if in the middle, then you must go from this side to this side. But if they are saying only if, then go in the same direction. Clear? So in the GATE exam, this is one of the difficult point where people might have a problem. Suppose I say today is Monday. Today is Monday if I go to movie. Look at today is Monday only if I go to movie. Don't treat both are same. Both are different. If comes in the middle, then go this one first, then take, then decide. If only if comes, then if take first, then apply here, then apply here. If today is Monday, then I go to movie. Everybody, so carefully use this sentence. If is very dangerous when you are using an English line. And you should know right now that how to use them, because in future you are going to use these two statements are different. These two are different. Everyone? Here the first statement refers, the first one refers if I go to movie, then today is Monday. Second one, if today is Monday, then I go to movie. Okay, interpretation is very, very important. Now, let's look at if and only if. Here, anybody is using P, if and only if Q means two things are covered here. What are they? One is covered, P implies Q. Let me use the word properly. The first if uses right to left, second the word only if uses left to right. That means P implies Q is covered and Q implies P, P implies Q. Two directions are covered. So that is used basically for biconditional. Fine, let's move on. Now look at other things. There are sometimes we use this P implies Q in some other terminology like which is necessary, which is sufficient condition. And look at when you are saying P implies Q, then you can say either of this. Either you can say this one or this one. P is sufficient. You can say this is sufficient for Q. Because if I know the P value, I know the Q value. If I say P is true, Q has to be true. If P is false, Q can be anything. Then look at when you know the P value, the Q value is with you. Everybody? That means P basically decides the Q, what should be the Q value. But when you know the Q value, that's not sufficient, but you can say necessary, that's all. It's just a necessary for P. Okay, I'm using capital Q. And similarly, P if and only if Q, then we use a symbol by implication. Now here either you speak P or Q, doesn't matter. Say anything. P is necessary and sufficient for Q, and I can also say Q is a necessary and sufficient condition for P. Both are correct. Both are correct because if P is true, Q has to be true. If P is false, Q has to be false. If you know the P value, indirectly Q value is also known because both are true or both are false. Yeah, here we have to speak necessary and sufficient, both will happen. Okay. Now let's look at some of the equivalences where you may use them directly or indirectly, and you may prove them if you want. But in this Sankalp batch, we are not proving anything. Just for safe side, I'm trying to explain them. When you are applying conjunction, like any proposition conjunction with a true value, the result depends on P, because if the P is true, then result is true. If the P is false, then result is also false. Everybody? So whatever the P value, the result is also same. Clear? Whatever the P value, result is also same. And in disjunction, any proposition statement disjunction with the false, then the result purely depends on P. If the P is true, then P conjunction with F also true. Right. Next. I hope you can understand this. P and F in conjunction, if you do false with any proposition, you will get a result false. Right? Equal to false. And P or true is a true. In disjunction, if any proposition is true, the result is going to be true. Whole interpretation is going to be true. And there are some laws. Of course, law names are not important, but law is important. Remember, some people by heart, this is absorption law, this is De Morgan's law, this is identity law. Right? Now here, you don't need the name of the law. because in the exam they do not ask what is which law, but there are few important laws like associative, commutative, identity, distributive. These laws are important. Everybody, even De Morgan's law, some are important but remaining are not that important. Okay, so this one you are using the same proposition with the conjunction, result is same, in disjunction is also result is same, and this is a De Morgan's law. Negation of negation P is the P, and P and Q is also Q and P. This is what? Commutative. That is going to be used in many subjects, in many topics, right? Wherever you get an operator, you might use this kind of laws, commutative or associative, something like that. And what is this law? P and Q and R, this associative. And if you look at conjunction and disjunction, they satisfy commutative, they satisfy associative, and they also satisfy distributive. And all the laws are holds in propositional logic: commutative, associative, and distributive. Clear, guys? And in the exam they may ask any of these three, because which are very important in discrete mathematics. Not only discrete mathematics, in whole computer science, these few important laws are important, like identity, associative, commutative, distributive. And this is a De Morgan's law. What is that? If you apply not to the any proposition, the not goes to P, and not and become R, and not Q become not Q. So that is going to be applied each and every component of the proposition. And similarly, when you apply not, not goes to P, and not of R goes to and not of Q appears as not Q. Clear? And this is absorption laws. Okay, what is this absorption law? And in digital logic also you might be using that. P dot P plus Q. You can write as a P, and P plus PQ you can write as a P. Of course you can simplify if you want it. Everyone, you can take the P common, you will get just P, 1 plus Q. And P and not P. Even absorption law also, you can get P plus P bar Q. You will get P plus Q, because P bar gets cancelled. So somebody can write P or not P and Q. You can write it as P or Q. But very complicated, guys, very complicated. And all these things remembering is very difficult, but you can remember only which are important for exam. And yeah, this P and not P will result false, P or not P, it will result true. Whenever you get it out, you can use truth table to prove them. You can use the truth table to prove them. You can interpret them properly. And some of the important equivalences that are going to help you in the actual exam, like P implies Q. Whenever you have it, always interpret as not P or Q. P implies Q, you can write as not P or Q. You can write as not Q implies not P. This is a contrapositive. This is the contrapositive. This is also very important. P implies Q, and contrapositive is also same as P implies Q. But contrapositive speaks not Q and not P. And also let me tell you some story. You know, P implies Q, when you have here, do you know what is this component? There are two components here. And this component is left side is called as, anybody? It's called as premise. It's also called as assumption. And Q actually called as conclusion. You know, it's kind of deduction. You are going to get that Q if you assume P is a true. And this entire thing is just like a formula, propositional formula. It's a proposition. And these things we will use in inference logic. Who is the premise, who is conclusion, who is assumption. Premise, assumption, both are same. Yeah. Everybody? So we need to assume always P is true, because why don't we assume P is false? If the P is false, the P implies Q always true. Then never, don't worry about when P is false. Always focus on when P is true. Is really Q true? So here remember the point, how do you understand this sentence? P implies Q means here true is there, it has to be true, and when false is there, we don't care, either true or false. So always this is important for you, because if you want to prove that P implies Q is the true, then just take that P is the true, then prove that Q is the true. And don't ever take P is a false, because always true. This is always, it's a trivial. This is a trivial, very easy to understand. Okay? Fine. And P and Q can be written without using and or. Even you can use negation 2 times you can apply. You can get that not P or not Q. You can write in disjunction, or you can write is this is gonna be. There are 2 ways you can write here. You can write P implies not Q, or you can say that. I'm sorry guys, it's going down. Okay, let me delete this one. Okay, this one I can write even not Q or not P. So now if you look at both of them, left side, this is not P or something, you can say that P implies not Q. Here also not Q or something, you can also say that Q implies not P. And the same thing you can write so many ways. Here not of P implies not Q also you can write. Yeah. Similarly, I am talking about similarly, you can prove by simplifying the P implies Q and P implies R. It has to be P implies Q and R. Right? Just like if today is Monday, I will go to movie, and if today is Monday, I will write an exam. So indirectly, if today is Monday, I will go to movie and I will write exam. Right? You can interpret an English line, then how to remember that? Everybody? So this is one kind of equivalence. Another equivalence is it's P implies R and Q implies R. Something like that. If today is Monday, I will go to movie, and if today is Tuesday, I will go to movie. See, look at the 2 statements. P and Q are different, but R is same. Indirectly, if today is Monday or Tuesday, I will go to movie. Everybody, how to interpret the next line? If today is Monday, I will go to movie, and if today is a Tuesday, I will go to movie. It means if today is Monday or Tuesday, I will go to movie. Right? So in premises, you got or when you are doing the conjunction over the 2 implications. Okay. Next, P implies Q, R. P implies R. Then look at now, you are using R statement, then it goes to P implies Q R R. Something like, if today is Monday, I will write exam, or if today is Monday, I will go to movie. R word is there. Then if today is Monday, I will write exam, or I will go to movie. It's just like conjunction, you have a disjunction here. Now similarly, a disjunction, P implies or, Q implies or. Now this time you have P and Q together implies R. And this is very dangerous statement. I hope this is very difficult for you. When somebody is speaking, if today is Monday, I will go to movie, or if today is Tuesday, I will go to movie. Indirectly, it's a very difficult statement. Sometimes a very difficult interpretation. If today is Monday and Tuesday, of course that never happens, right? But be careful when you use such statements. But this is how it is interpreted. This is how it is interpreted. P and Q implies R. Okay, so this is going to be difficult compared to other three. And remaining, you know, P by implication. Yeah, the last one, negation. When you apply for by implication, you got you can prove that P by implication with negation Q. But don't try to remember in the exam. If they ask, you can prove at that time. If anything which looks important, you can remember it and you can apply somewhere. But if it is not applicable in most of the questions, then you no need to remember it. So those properties, those equivalences which requires oftenly or require frequently, then we use them and we remember them. Good morning, Nikhil. Okay, let's move on. What I want. So before starting the actual topic, that is inference logic, let me help you who joined late. And this is the first batch started. This is batch A. Now, of course, there are so many batches are going to come along the year, B, C, D, and so on. And you may use a referral code if you are interested to join this batch. In case if you have any doubt regarding plus or iconic subscription, you can contact the customer support or you can contact us. We are always there to help you. Okay, now this is what the topic is, inference logic. And most of the gate questions looks lengthy and difficult, but that can be solved because of this inference logic. And whenever you see the implication, inference logic can be applied. Inference logic can be applied. So how inference logic is defined? Here, inference logic depends on the set of arguments. Depends on set of arguments. Everyone, depends on set of arguments. Then what are these arguments? Here, you know, A1, A2, A3 and A4, any number of arguments, doesn't matter. All these arguments are there. All these arguments are there. Somebody saying P implies Q, somebody saying P and Q, somebody saying not P, and different arguments are there. All are propositions, but here it might happen few arguments are premises and some arguments can be conclusion, even A5, but I am not writing A5, that's okay, A4, and here some of them can be conclusion. So what is this premises and conclusion? That's what we are going to understand. The whole system is called as inference logic. So you have set of arguments, set of premises, and these things will prove A4 is the conclusion. You can represent as the set of premises, also called as set of assumptions. Premises also called as assumptions, and these assumptions will prove the conclusion is the true. Okay, let me talk about that. Okay, I'm sorry. Let me talk about that. Okay, here let me say something A1, A2, A3, and you got conclusion, that is this is therefore A4, and this whole system is called as inference. I'm just representing inference system. And second, the same thing you can represent as like A1 is there and A2 is also true and A3 is also true. Can you prove that? Can you prove that A4 is also true? And if you can prove that, this is a tautology. If you try to prove it, this will be a tautology. And this inference, we call it as a valid inference. And third one, you can also represent A1, A2, A3. All these premises will help you to prove that A4. This is inference. How do you represent? Everyone, all these are representations. All these are representations in English line. English line meaning is very simple. What is the meaning of this? By assuming A1, A2 and A3 are true, we can prove we can prove or we should prove, that is important, we should prove A4 is also true if inference is valid. If it is invalid, we can't prove as a true. It may be sometimes true, sometimes false. Everybody? So here, these are called as assumptions, are called as premises. These are given to you. This you need to assume. But they are true. They are true. Everybody? So A1 is true, A2 is true, A3 is true. Then can you prove A4 is a true? As long as you don't understand this inference system, then it's very difficult to apply in the exam, but it will become so easy. Even those questions which takes 5 minutes can be answered within a minute if you know the inference logic. Okay, let me try some inference logics. Okay, something. Suppose somebody is given P and somebody is given Q, and can I say that therefore P and Q, is this inference valid? If it is valid, definitely I can prove tautology by doing something. Is it correct? Like if P is true, if Q is true, can you prove that P and Q is true? P is true and Q is true. Can you prove P and Q is true? Always. So we can say P and Q is a conclusion. And not only that, you can write P or Q. Not only that, you can write P implies Q because both are given. Everyone, these all are valid conclusions. But when somebody is saying not P or not Q, can you prove that not P or not Q is the true? Impossible, because when P is true, Q is true, not P or not Q is the false, then definitely this is invalid. It's not a valid conclusion. So I can write in the exam, P and Q implies P and Q. This will give, if you try to simplify, this is going to be equal to tautology. Not only that, P and Q implies P or Q, and P and Q implies P implies Q, and all of them will result tautology. Everybody? But if anybody asks P and Q implies not P or not Q, you have to say it is not tautology. Everybody? So this is not tautology. You need to identify, is it satisfiable, is it falsifiable, or is it something else? This is not tautology. That is true. It's not valid. But it might be contradiction, it might be satisfiable, that depends. Okay. So let me go back some things I forgot to remind you. Did I use the words? Okay. Sorry guys. Okay. Now have you remembered these words? Satisfiable, falsifiable, because I am using these words. If you do not know the definition, it might be difficult for us. Contradiction and a contingency, it's neither tautology nor contradiction, that's okay. This 4, satisfiable means at least one instance or at least one interpretation is the true. At least one instance or one interpretation, at least one interpretation or at least one instance or at least one row in the truth table. At least one interpretation is true. At least one interpretation of given proposition is a true. Falsifiable means at least one interpretation is a false. And tautology means every interpretation of the given proposition, every interpretation, whatever the values you put, every interpretation is the true. And contradiction, every interpretation is false. And contingency, if you want, that is neither tautology nor contradiction. Rishabh, graph theory will be covered from tomorrow, will start from tomorrow. Rishabh. Okay, so in case if anybody, suppose if I say P and Q, what is it? We can say it is satisfiable, because not everybody is the true. Some interpretations are true. It is also falsifiable. When it is both satisfiable and falsifiable, there is a contingency. And when you say P and not P, what is going to be here? It is always false, right? So that is a contradiction. Of course, every contradiction is a falsifiable. Yeah. Every contradiction is a falsifiable. Let me tell you some relations. Wait. Tautology propositions. All these propositions are tautology. And all these propositions are, let's say, contradiction. Contradiction propositions. And you will get something like these are satisfiable formulas, satisfiable propositions. And this is these are falsifiable. Falsifiable, at least one instance. And जो बीच में है ना, then बीच में कैसे लिखूँ यार, थोड़ा स्पेस चाहिए. So in this, some propositions which will satisfiable and falsifiable, they are called as contingency propositions, which satisfies both satisfiable and falsifiable, and they are neither tautology nor contradiction. Neither tautology nor contradiction. Everybody, look at that. What is the relation between tautology, contradiction, falsifiable and satisfiable? That means not tautology doesn't mean that contradiction. Not tautology means it can be contradiction or it can be contingency. So whenever you say some propositional formula is not valid, means do not assume false. Be careful about the valid and invalid. Example or satisfiable, P R Q. Okay, that has two answers. Here you have P R Q, that can satisfy, that can do the also falsify. P R Q, you can get a true, you can get a false. And when you have P R not P, that is always tautology. And when you do P and not P, that is always a contradiction. Everyone? Yeah. तेजस, अरे यार समझ नहीं आ रहा है, P R Q दिया हुआ ना यार, P and Q दिया हुआ ना. This all are falsifiable and satisfiable because this can be true, this can be false, depends on the values that you put. At least one interpretation is true, at least one interpretation is a false. होता है ना यार, इनको यार क्या बताऊं लोग को. जब P R Q बोला, do you have at least one interpretation? When P is true is enough, right? When P is true, true or anything is a true. That means this is satisfiable. You can say this is satisfiable. And when you say P is equal false, Q is equal false, you got P or Q is a false. That means falsifiable. You can make false, you can make satisfy. Yeah. Everybody, that means this is a satisfiable and this is also falsifiable because two kinds of interpretations are possible in the same proposition. But when you take P and not P, to put whatever, the result is gonna be false. That is called as contradiction. Here I say here, at least one instance is makes true. It's not possible, right? Any interpretation you do, the result is false. Put a P is true or false, P and not P always comes as a false. So it's called as contradiction. P or not P. Put any value of P, doesn't matter, it always comes as a true, means it is a tautology. And P or Q, sometimes true, sometimes false, it is contingency, neither tautology nor contradiction. Okay. Okay, there are so many inferences, they are all valid, but for the exam point of view, you no need to remember the names, but remember the concept. First one, let's look at P implies Q and P. How do you get a Q? This modus ponens is nothing but the P implies Q and P. It means is that P implies Q. P implies Q. It means P implies Q and P implies Q. That you have to prove. It is a tautology. But I don't prove that way. Look at that. Yeah, looks like there is a server issue. Fine. Now I want to prove. P implies Q and P. This is what I want to prove, right? In the first one, this is a valid inference. Not only that, everything that I have shown on this slide is a valid inference. But how do you prove it? And don't try to remember the names today, because you are not doing the research in discrete mathematics, right? If you are doing it, you can remember every name. But if you spend much time, you will definitely remember the names. But I don't want you to remember the names. I want you to prove every inference. In the exam, they can ask any inference here. And this is the first one. This is the first one, let's say. And why this inference is valid, I'm trying to tell you. Assume these premises are true and prove that conclusion is true. Assume premises are true and prove that conclusion is true. That means this inference is valid. Everybody, otherwise you have two choices. Prove P implies Q and P implies Q is tautology. Prove that it is a tautology. Construct the truth table and show that entire column of this proposition is a true. Or you can prove another way. Assume A1 and A2 are true, that is P implies Q, and P are true, and show that Q is true. That's enough. By assuming P implies Q and P are true, show that Q is true. Now look at how I am going to prove. I am assuming that this entire P implies Q is a true. An entire P is a true. And sometimes while you assuming, you might get some truth values of variables and take them and substitute and find out others. That is how we do quickly. So when you assume P is a true, then P implies Q, this side true happens. Which side? This side true happens. And true implies Q, then Q has to be true. So what we got, when we assume P implies QP, you got two values, that is P we got true, and because of that we are also getting Q is true. How did you get that? Because when I put P truth value in the P implies Q, then Q must be true because P already true. Then therefore you can write a Q because Q already true we got from assumptions. Everybody? Now Q is true. Now put that Q truth value here, then definitely that conclusion is the true. But you can't say not Q. If you say not Q, that inference is invalid. And whatever the inference I have written on this slide is definitely a valid. Look at that. Not Q, put a true. Then what happens here? Q is a false. And put here is equal true. And what happens here? P implies false is equal true. And आपको true चाहिए. Then true के लिए P has to be from this P has to be only one option. P has to be false, then only false implies false will be true. P is false. P is false, Q is false. Then definitely when you substitute in the conclusion, then this one not P definitely true. Because I substitute here, I got true. Everybody, the conclusions will become easy if you understand assumptions. Assumptions are going to help you to prove what is the conclusion. And this is straightforward conjunction. P is true, Q is true. Obviously P and Q has to be true. And the transitivity, you can remember it. P implies Q and P implies Q and Q implies R. Why transitivity? P implies R, you can remember, but you should know, is it valid? All of them are valid here. Look at now, assume P implies Q is true. Assume Q implies R is true. Now using this, you have to prove P implies R is true. How do you do that? How do you do that? You can P implies, transitivity you can remember, but you have to prove it. You have to prove it. How do you prove that? Either tautology, you can consider the truth table, you can show that it is a tautology, or I can show that I am assuming this is true, this is also true, then I will find out the truth values. Okay, first one, not P or Q is a true. Second one, not Q or R is a true. Now here so many cases might happen. So you can take one after other. Here if I take suppose P is, let's say, true. Do you require any other? Just check it. P is true, then this will become false. Then Q has to be true. Because P become false. Are you clear? If P is true, then this will become false, not P become false. Q is the true now. Q has to be true now because result is true. And we got P is true, Q is true. When you assume P is true. And what about R? When Q is true, put here false you got, R has to be true. This is the one situation when you assume P is true. But other situation may happen when you put P is false. When you put P is false, Q doesn't matter. Q can be either true or Q can be either false. There are two situations. If the Q is true, no problem in the first assumption. Second assumption, if the Q is true, then R has to be true because not Q become false. And if the Q is false, R can be any again. R can be true, R can be false. Now only total 4 cases are there for you. And by taking these cases, Is it always true? P implies R. Now look at, whenever this is true, R is true. The first case, and in the second case, look at that. Let me write the cases. And this is a case 1, this is a case 2, and this is a third case, this is a fourth case. There are 4 interpretations are there now. First interpretation is over. Second interpretation, P is false, R doesn't matter, but still it is true. False implies true is true. And third interpretation, that P is false implies R is true. It's fine. Third is also same. And second, third, fourth, they are trivial because assumption the P is already false. That doesn't matter whether R is true or false. Whether R is true or false doesn't matter. Everyone, so this is how we can prove the conclusion is going to be proved from the given assumptions. Everybody, no, I'm not going to prove remaining, but just I'm trying to say, yes, all these are laws, all these are rules, and everything you can prove here. P or Q, not Q. Look at here, not Q, assume true, then you got Q is false. When Q is false, you put here. We already know this is a true. Then when you put Q is a false, then P or false is a P. P is equal true, you get it. P is equal true. Then P is equal to Q is equal false. Then you can write a P as a conclusion. Okay, similarly, every inference here is valid. Every inference is valid. And also remember, for given assumptions, these are assumptions. How many conclusions are there? Infinite conclusions are possible. So in the exam, that is the reason it will happen. See, data may be same. Suppose I have written, let's say P, Q. I can say P and Q. I can say P or Q. I can say even P or not Q. I can say all are valid conclusions. All are valid conclusions. I can say Q or not P. I can say P implies Q. So many inferences in the valid. So many inferences are valid because of these assumptions. So by writing P and Q implies so many here, so many conclusions, I can prove as a tautology. Everybody? That is the reason this is a very popular question in the exam. Fine. Okay. So I hope you understood. Now look at one example. How to check, is this inference valid? They might give you some inference. They will ask, is it valid? तो आपको क्या करना था? अगर आपको inference ही आता नहीं है, so just go for conjunction of every argument in the premises. Then prove that this implies R and whole proposition. Then construct the truth table. Prove that it is tautology. But which takes much time. We don't do that in the exam. Those people who are following tautology definition, they waste their time. Clear? But instead of that, what we do? Okay, we assume this is true. This is also true. This is also true. Now we will try to get the values. Okay, from this you can get P is a false. We got one. And when the P is a false, we got this one. False or Q is nothing but Q. Right? So directly can I write Q is a true. From this I can get Q is a true. And when Q is true, from here true implies R. I want to prove the true. Then what do you mean by R? R has to be true. R has to be true. Because we got the values, and by taking that values, check it. We got R is true. That means R is a correct proposition. Everyone? Correct conclusion. Correct conclusion. Not only R, you can write Q and R. I can write not P and R. I can write what else? Q R R, because already R is true. So many conclusions are there in the world. They only given one. That's so easy to prove. R is already true. Put a true, you get a true only. Clear? This can save a lot of time. Okay, I hope proposition logic you have clear little bit, because in general we take hours of the content for only explaining proposition logic. Now I have explained just 1 hour. I hope that you have covered, you have understood the important concept in proposition logic. Yeah. And if you have joined late, guys, please like this session. Please like this session. Now we will move to first order logic, and in the first order logic we deal with predicate statements, and in the predicate statements we use the quantifiers, and in this is very important, English statement to predicate logic, and they will give you English statement and they will ask predicate logic, or they will give you predicate logic and they will ask equivalent predicate logic, and these two are important topics. For that, you need to understand remaining all topics. What is predicate, what is quantifier, what is relation. Otherwise, these two topics are not easy for you. And most of the people, why they are not able to write predicate logic, the reason is understanding the definition. Okay, let's start from the basics. Okay, what is the first order logic? And in the first order logic, we'll try to reasoning about the properties of objects. Properties nothing but operations we apply. We relate one with other. We apply some functions, right? We are going to do some kind of properties, nothing but operations only, right? We try to operate the objects, right? So if this is going to help you, the one that is, you can apply some operations over the objects of the domain, So here the first order logic depends basically on, predicate logic depends on domain. In the domain you have objects, and what do you do with these objects? We do some kind of properties on these objects. We relate one object with other object, or we perform some function on object so that you will get another object. Everybody? But in the propositional logic, do you have such things? You don't have a domain. Are you clear? You have facts. You have the facts, either true or false, that's all. But here each object can talk about the fact. That means you are trying to apply the propositional statement on every object of the domain. Yes, भावना लॉन्च होगा ना? क्यों नहीं होगा? थोड़ा टाइम लगेगा, बट लॉन्च होगा ना? Everybody, and look at here with the words that we use. Predicates. What is predicate? Right? It describes the properties of the object basically. If I say a student, X is a student, here student is a predicate. We may write something like student of X, where X is the object but student is the predicate, right? Because it could be any object is a student. You do not know that. And functions. Sometimes we apply functions or properties, relations, operations here like X comma Y. That means X likes Y. It's kind of a property we are looking for. Property. X likes Y. You are mapping or relating one with other. Everybody? So it's like a function. Or you can say sum of X comma Y. You want to add two numbers but you are not saying X plus Y. You can also say X plus Y. Operator is also fine. That is a function. And quantifier, that allows us to reason about multiple objects simultaneously. Like for all X, means I am talking about every x, and there exists x means I am talking about some object in the domain. And for all x means every object in the domain, there exists x means some object in the domain. Anyhow, it's just a definition I am talking about, not definition, it's just the terminology that I am talking about. When you are dealing with first order logic, and remember there are predicates, remember there are functions, remember there are quantifiers, not only these three but many other too. Like if you are writing one predicate statement, look at what's gonna be there inside. What's gonna be there inside? Everyone, a predicate statement can deal with so many things. Is it clear? Here you will have objects. Here you will have objects. Of course, predicate symbols are different, so you can say objects and constants. Sometimes name is a constant. Somebody, you are using the name of the person, or 23 constant value you might be using. Names and functions, relations, operations, they talks about properties. And predicate symbols like student, p of x, here predicate symbol is a p, this is the predicate symbol, and x is the object. And for all x, and this is a quantifier, and sometimes we connect with somebody else, then this is the connective, and constants are not visible. Sometimes it will be there, like you have fixed constant, let's say q of x comma 10 are there. You can also write a name, suppose, then this 10 is a constant, that's not going to change. Everybody, and sometimes r, this r is what? Okay, not r, let me write proposition. Even proposition also I have inside, and sometimes let me write r of y. What is y here? There are two things. X is bounded because we have used a quantifier to define the x, but y is a free variable. Y is free because y has no quantification. Everybody, look at in one statement you have so many things. You have objects, you have constants, you have properties, functions, relations, operators, anything. And predicate symbols, that's p of, q of, p and q are predicates, and quantifiers and connectives. And that is what the predicate statement. When you are talking about predicate statements, so many things are going to happen. But have you understood each and every word of here? And mainly quantifier, have you understood it? That's going to help you to understand entire thing. Everybody? Yeah. And when you use a variable, every variable must be used properly, quantified. Every variable must be quantified properly. If you did not use the quantified, then it might be free variable, may not understood properly. Okay. Now some people requires the definition of this quantifiers. Let's focus on that. There are two types of quantifiers. Of course, you might have other, but these two are enough to define any other. Universal and existential. Universal quantifier we represent with for all. Existential quantifier will represent with the symbol that exists. Okay, so you can speak as like for all, or you can speak as for each, or you can speak as for every. And there exists, you can speak as there exist, or you can speak as some. And there is one word which is very difficult, any word. Sometimes it is applicable any for all, sometimes applicable for there exist. So better to avoid this any word because which may come in both of them. So better to avoid. If somebody gives any word, then understand as per their statement, because this can be used in both the statement, both the quantifiers. Okay. And also be careful when you are dealing with quantifiers. The quantifiers will use will help you to bound which objects you are talking about in the domain, and free variables will not help you. Free variables are different from bound. Okay. Now what is universal quantifier? How to understand using predicate logic. Suppose anybody writing for all x p of x. First, how many ways you can write this? The for all x p of x you can write as for all x comma p of x, or you can write for all x p of x, or you can write for all x p of x even parenthesis. It's all your choices, but you should know precedence rules when you are using them. What precedence rules? Like precedence rules. If you do not know, please remember them. For all and there exist will come as highest precedence. Then when you are using the connectives, not comes first, then and, then or, then implication, then by implication. So this is the precedence table for predicate system, and this is highest precedence and this is the lowest precedence. And first you need to focus on quantifiers before looking at others. And sometimes even comma also I can use. If I use the comma, then it should be lowest than anybody. Remember, it should be lowest than anyone. Clear this point? Okay, example. For all x p of x for all x comma p of x implies q of x. How do you speak that? First you need to give priority to the for all. So first we apply this one together, and then comma is there, comma is lost, and implication, right? You have implication next, so you will apply to this, then comma, then you will apply. That means you are trying to speak for all x p of x implies q of x. This is what I want to speak. Is everyone clear how to use these precedence rules in the predicate system? Come on, please reply guys, and also like this session, Right. If you are not aware of these rules, please remember them and apply them carefully. Yeah. If anybody writing, for all x there exists y p of x implies not q of y. Suppose somebody writing like this, even including, let's say, a comma, right? So how difficult it is if you don't know the precedence rules. Very, very difficult if you don't know the precedence rules. How do you apply? First look at who is highest. Okay, for all x there exists y, both are highest, applied it. Now not is there, so apply not to the predicate q of y, and then connective, so this will connect next, and then you need to apply comma, then you will apply to this. Okay, yeah, you have other example. Yeah, Rishabh, please rewind the video, right? Otherwise, go to the C programming and first learn precedence table, then come back to here, right? Normally the precedences will not be spoken in discrete mathematics, but for understanding, you are computer science student, so you should know about this. In the exam, they have already asked without parentheses, then you must interpret properly. You should know how to interpret it. For all x, there exists y, and you must know how to apply it. P of x implies not of q of y, and you should know how to apply it. Fine. छोटी चीज़ को बड़ी करके पढ़ाया, और इसमें भी डाउट आ रहा है, मतलब very difficult to handle brain. Okay, now is that clear why I am writing this all things? I know for all should be x with x, and comma should be last. So first p of x right side and for all x left side, and I applied for all x to p of x. And here for all x you can also write this way. Clear this point? And many ways to represent the same notation. And this is a simple. If you understood this is a simple, so you can use that. Okay, now what is the meaning? I was talking about a definition. Yeah, thank you, Tismarkan. Chandrasekhar. Yeah, we will create separate batches for Hindi and English in future, no doubt. Don't worry, Chandrasekhar, we will. Now, how to understand this universal quantifier? What is the definition? And remember, definition depends on one thing, that is a domain. If you forgot your domain, you cannot understand the definition. That means anybody says for all x p of x, it means you are going to apply on every element of domain, like p of x1 and we are going to apply p of x2 and p of x3, and how many? If it is finite number of objects in the domain, you will just take finite time, otherwise it just goes infinite time. But this is to be true, right? For all x, p of x, for every x, p of x is true. That is how we speak. For every x, p of x is true. How do you apply that? The conjunction of the predicate over every object in the domain. Conjunction of predicate over every object in the domain. Everybody? Okay, let me give an example to understand. Suppose I have domain 1, 2, 3, and I said p of x, I said that x is natural number. Another one, q of x, I said x is even number. And r of x, x is prime number. Let's say that. And s of x, let's say x is less than 10. Now tell me which predicate gonna be true for this domain. Here P of X nothing but, okay, now let me write. I've not written it. For all X, P of X means every X is a natural. You're talking about every X is natural. Is that true? Is that true? Yes. How do you know that? P of 1 I applied, P of 2 and P of 3. Everybody is saying true. So result has to be true. So that has to give a true. And if I say for all X, Q of X, means you are trying to say every X is even. Every X is even. Is that true? You are trying to apply Q of 1 and Q of 2 and Q of 3. 1 is a false, 2 is a true, 3 is a false. Then definitely result is a false. Have you understood how to apply? You can't speak like English line. You need to go to each object and you need to apply. And if domain changes, let's say for this domain you got it. And if I change the domain, let's say -1, 0, 1, then P of X is a false. Because every X is natural is the false. Now here any predicate can be for all X. I am talking about here. For all X, P of X is false for this domain. And which predicate is true, which predicate is false, that purely depends on the domain. जब तक आपको domain समझ नहीं आता, if you don't understand the domain, there is no need to study this chapter. It's a purely depends on domain. Now, first example. Every X is even. This is English line. Is it true or false? I am asking everyone. This is my statement. Every X is even. Is this true or false? Because I said that I need something. So I need to prove that what I need. Every X is even. I have to see the reply from everyone, guys. Is it true or false? Yes, Lavjit. Satyajit. Only 2 people are asked, sir, where is the domain? That is what the question is. Yes, Shiva, that is what. You cannot answer it is true or false until unless domain is given. I am not talking about a domain, right? Without domain we should never say it. This can be true, this can be false. Look at now. D is given, D1 is given, let's say 2, 4, 6. Now what happens to this statement? Let's say this is E of X. For all X, E of X. Now what happens here? For all X, E of X will become true. But if I take domain is 1, 2, 3, 4. Now here for all X, E of X is gonna be false. Because every X is not even. Every X is even, you can't say no. Now without domain you can't speak at all. Give either finite or infinite domain, but domain is there. Everybody, so don't judge English lines. Everybody, every number is even. This is same as every number is even. In that case, which number you are talking about? First tell me about it, then I will decide whether it is true or false. So domain, domain, domain. So I have another way to define this definition. You can say some other way, guys. For all X, belongs to domain, you will apply P of X. This is how actually we should think about. Here domain is a D. Everybody? So definition always depends on domain. But normally we avoid because domain is assumed based on the question. Okay. Clear? Understood? Similarly, can you apply R of X, S of X? Right? If I ask for all X, R of X, is that everybody is a prime? No, right? False. And if I apply for S of X, is that everybody is less than 10? Yes, that is a true. Understood? It depends on the domain. The predicate system is going to evaluate it as a true or false. Okay, let's move on quickly. Existential quantifier. ऋषभ पहले एग्जिस्टेंशियल पढ़ाने दो यार, अब बीच में आया और लास्ट में जा रहा है सीधा। ऋषभ पहले पढ़ाने दो यार, एग्जिस्टेंशियल डेफिनेशन नहीं आया तो बाद में आपको जो चाहिए वो पूछो डायरेक्टली, इंग्लिश लाइन मत देना, सीधा पूछो क्या चाहिए आपको। Existential quantifier, you represent with there exists, right? So there exists X, P of X, and in the domain you can speak that there exists X belongs to domain, you are going to apply. In the domain you might have finite numbers or infinite numbers, or finite objects, infinite objects, that depends on the domain. Okay, now what is the definition of this one? It's same as P of X1 or P of X2 or P of X3 and so on, depends on how many objects you have. How do you speak? Some X, P of X is true. That means there exists X. Some means at least one. I forgot to tell that here at least one. Existential talks about at least one. Right? At least one X definitely there. Where P of X definitely true. Clear? Suppose if I take similarly 1, 2, 3, I have written prime of X, means X is a prime. This is my predicate and I am applying predicate logic now. I am saying there exists X, P of X. Now tell me what is answer. Is it true or false? Is it true or false? How do I know is true or false? For the given domain only, Domain to domain answer changes, domain to domain answer changes. Is it true or false? You will apply P of 1 or P of 2 or P of 3. And P of 1 is a false, P of 2 is a true, it's a prime, 3 is also prime. Then false or true is definitely true. At least one prime is there. But when I say for all X, P of X, in that case it will become false because one of them is a false, the whole result is a false. Here you apply different way. Everybody clear? And now we can begin this concept. What I need from this predicate logic and what we have to focus, we will start now. Are you ready? Okay, before converting English statement to, and in this predicate logic, in this predicate system, and remember domain is going to play a lot of important role, very important role, because if you did not focus on the domain, if you don't focus on the domain, then you might be answering wrong. because domains can make a different answers. Domain and quantifiers apply properly, and domain and quantifiers handle them properly, the predicate logic will become so easy. Will become, in quantifier two things are there. One is definition, other one is interpretation. Definition you understood, but interpretation you have not understood yet. The interpretation applying is different. How do you apply is going to be different. Everyone, definition will give you basically a meaning of that quantifier. Everyone, domain, is it finite or infinite? If it is finite, what is your domain? If it is infinite, which infinite? Okay, ready? Okay. The first one, I want to differentiate first how a propositional statement you write, how a predicate statement you write. Everyone, look at the first one. If this is the predicate logic, even I can say student is clever. I no need to say every student is clever. Even I can say all students are clever. Singular I no need to use, plural I can use. All students are clever. Everybody in the predicate system. But if it is propositional system, you may say simply student is clever, that's all. Particular student you might be talking about, that's why you are using the statement. You may simply use C. E is the variable in the proposition. In the proposition, we cannot speak about every student. We might have only one student, so we might be talking about. Everybody, so in proposition, simply student is clever, but only one student is there. But here domain we have, what kind of domain? Domain. What is your domain? I am not writing first, guys. What is your domain? Do you have only students here? That is the problem. In the universe, students are there, faculty is there, educators are there, animals are there. You don't know which object you are looking for. If you are looking for only people, here students are there, educators are there, employees are there in the world, and which person you are looking for? Anything. Private employee, government employee, right? I am just talking about two things, but many are there. I don't know exactly how many kind of objects are there in the domain. First, let me help you how to understand this problem. Clear? Have you understood what is your domain? I might be talking about the student, but I may have a student, I may not have a student in my domain. Because this statement must be applicable for every domain that I write. For every domain, it should be applicable whatever you write. So I am going to write a predicate logic now. Okay, I have two questions now. Every means everybody uses for all, right? Now student is one object, you are applying with other. Now here I am going to use S of x means x is a student, and C of x means x is a clever. And this is straightforward, but one thing which happens, this is and. That is it and or implication? There are two problems happens. For all x, S of x implies C of x, and for all x, S of x and C of x, and tell me which is the right answer. There you will have a clarity. What is the right answer? I am asking the question, what is the right answer? यहाँ पर लोग फिल्टर हो जाता हो. it is applicable for every domain in the world. Any domain you take, it is going to verify properly for any domain. But second one, it is applicable only when domain has only students, nobody else. Look at the difference, everybody. And when you are using and domain, of course not empty should be there. When non-empty domain that has only students, then second is also applicable. In the exam, you do not know what do they ask. Always the first one is preferred because they did not say the domain. Second one is preferred only when they mention I have a domain in which only students are there and definitely students are there. Then you can use the second. Is that clear? Second is applicable only for the domain when students are only there in that domain, nobody else. Clear? This is where the people filtered. Example, look at, I have a domain, let's say student 1, student 2 and educator 1, okay, and assume, clever or not, it's fine, I am assuming clever because I want to prove true, right? I want to prove true. Now I am saying that for all x, S of x implies C of x. Do you know how many objects are there? There are total 3 objects, x1, x2, x3. 3 objects are there. Here 2 things. The first definition, this is a definition and this is interpretation. Both things are there. Don't look at both simultaneously. First look at definition. What definition says? Every object I need to apply my condition. What is the condition? Whenever we get a student, he must be clever. So let's try. x1, how do you apply? You need to apply 3 times conjunction. Everybody agree? How many times you apply conjunction? This is the definition. This is the definition. And what is the interpretation? Okay, S of x1 implies C of x1. S of x2 implies C of x2. And S of x3 implies C of x3. And E doesn't matter clever or not clever, is your choice. Now you know x is a student, true. And I already said it is a clever. So true implies true. And S of x2 true, C of x2 true because it's a clever I have given to you. And true implies true. And this is the false because x3 is not a student. So you can't apply. You can't apply the condition here. You should not apply clever condition here. You should not apply interpret here. You should not apply clever here. Is clever or not doesn't matter to us. So false implies anything is a true. That means this is gonna be true because every student is clever here. If any student is not clever, then definitely some object you will get a false. शांति, यहाँ prepositions नहीं होता, propositions होता. Prepositions is not English. यार यहाँ prepositions नहीं होता, prepositions होता. And शांति, आपको क्या preposition चाहिए ये बात कर लो पहले, है ना? Are you there from the beginning? इनको propositional predicate में proposition चाहिए, मैं क्या करूँ? Right, everybody understood how to interpret one statement. definition बोलता conjunction, interpreted बोलता implication. So two things are there for all. Whenever use the for all, इसका definition होता and इसका interpretation होता implication. It has interpretation, implication. Clear? In English conversion, in predicate logic, in converting, understood everybody? For all, how do you interpret? Every student is clever, is implication. Okay, I hope everybody understood this statement. And we should not prefer this in general, because that is applicable only when the domain has only students. Okay, next. Now, some student is clever. इसको बोल सकते हैं some students are clever. Singular, plural, कोई भी लिख सकते हैं आप. Some students are clever, or I can say at least one student is clever. Or I can say there exists a student who is clever. And whatever I write, do you get the same meaning or not? In my domain, at least one student should be clever. Yeah. So now you know some definitely use there exist x, and student definitely s of x, let's say clever, let's say x is clever, because we don't know which x you are talking about. We need to look at every object in the domain. And what is now? What is now, everybody? Now we have two problems again. Should I write there exists x, s of x and c of x? This is the first problem we have. And second problem is, should I write there exists x, s of x implies c of x? Which one is right? And this statement should deliver at least one student has to be clever in the domain. But you know, second statement, what is going to happen? There exists x. Let me talk about this. Why we don't write this one? Why we don't write this? Look at, I have student 1, student 2, and you know, even I don't need anybody. Let's say this 2. Both are not clever, let's say. Both are not clever. Then this statement has to be false, right? This statement has to be false, right? Because no student is clever. इस domain में predicate logic बताना है false. Every student is, some student is clever. False बोलना चाहिए, लेकिन ये बताएगा true बताएगा. देखो इसका meaning क्या था? Definition और इंटरप्रिटेशन आप किया था इम्प्लीकेशन. पहले ऑब्जेक्ट को बना लो, s1 x1 x2 मान लो. तो s of x1 implies c of x1 and s of x2 implies c of x2. ये s of x1, I'm sorry, एक ले लो ऑब्जेक्ट, s3, ये x3 ऑब्जेक्ट, ये है कुछ भी, क्लेवर और नॉट क्लेवर, आई डोंट केयर, एनी। इसमें देखो ये S3 is not a student, let's say is educator, let's say educator, I'm sorry for that. Okay, everybody, there is one more R you need to apply on educator too. So S of x3 implies C of x3. Now look at, I have students in the domain but no student is clever. मैं तो बता रहा हूँ some student is clever, ट्रू यहाँ पर फॉल्स आना चाहिए, लेकिन क्या आएगा देखो, दिस इज व्हाट, ट्रू, दिस इज फॉल्स बिकॉज नॉट क्लेवर बताया ना, तो दिस वन इज जनरेटेड एज अ फॉल्स एंड सिमिलरली द सेम आंसर फॉल्स, बट यहाँ पर क्या आएगा, S of x3 is the educator, is not a student, x3 is not a student, so you get a false. False implies any कुछ भी, true or false doesn't matter, तो ये फॉल्स, ये ट्रू आएगा, देन आपका आंसर ट्रू आ रहा है, अभी गलत है ना, इज ट्राइंग टू से सम स्टूडेंट इज क्लेवर, है ना, दिस स्टेटमेंट कैनॉट गारंटी सम स्टूडेंट इज क्लेवर, कैनॉट गारंटी सम स्टूडेंट इज क्लेवर, but it will guarantee if you have only students in the domain. Yes, Rishabh, if you have only students, it will guarantee, it will guarantee if domain has only students and at least one student and only students, then definitely guarantee true means somebody is clever. आप logically देखो, इस domain में only students are there, I'm saying some students is clever, तो जो ये है ना, the disjunction, if one of them is true, then their exists will be true, right? One of them will be true only when at least one object makes true. Yeah, if not educator present, if nobody else present, only students are present, at least one student present, then definitely this statement will work properly. So in general, the second one is not applicable in general, not applicable in every domain. यही तो दिक्कत हो रहा है, but this is applicable for any domain. Clear everyone? So now you need to remember one thing, that is when you use there exist, two things. One, definition is very clear, it's a meaning. Definition is R, that's a meaning. But when you interpret it, when you apply to somebody, you must use and. In logic, you must apply and. Okay, next one. Every student, now I am not going to explain this quantifiers, it's over. Now let's write quickly. Every student is not clever. Clear enough? For all, S of x, C of x but not, and is implication. Over. Is it over? That's all you have to do. For all x, S of x implies not C of x. But in the exam, they may use something, P implies Q. Already know the logic. Not P or Q. You can also use this concept here. You can write in further not S of x or not C of x. Everybody? So many equivalent statements are there, so that you take care of it. Please. Okay, every non-student is clever. Every non-students not S of x and C of x and is you know implication over for all x not S of x implies C of x, and you may apply even P implies Q definition, then not of not will be S or C of x. Clear? Very easy if you remember definition and implications. Definition of quantifiers and definition of implication, then it will become very easy. Because every time we may apply P implies Q definition here. Okay, now every boy and girl is clever. Let's see who will answer. Now every, you know, for all. Boy, B of x. G, girl, G of x. And clever, let's say C of x. अब बताओ ये दो चीज है, बहुत गेम प्ले करता हूं. इस मतलब डेफिनेटली इम्प्लीकेशन. और अब बताओ एंड क्या होगा. कम ऑन, एंड क्या होगा. कंजंक्शन होगा, डिसजंक्शन होगा. एंड कंजंक्शन होगा, डिसजंक्शन होगा. क्विक. एंड कंजंक्शन और डिसजंक्शन. जल्दी बोलो, वी हैव टू क्लोज दिस सेशन. यस, गुड पॉइंट, गुड पॉइंट. ये होता आर. क्यों? देखो ना, if anybody writes, now 2 points you have again. The people, look at the first one. For all x, B of x or G of x implies C of x. Another one, second one, because conjunction लिखते रहो. And G of x implies C of x. And in English you say and, but in logic if you say and you will get a meaning. Here what you are trying to verify, object is that person is both boy and girl. Is that possible when you are checking for boy or girl individually? Come on, come on. Object is it possible both boy and girl? You took a person, you are checking is a boy, is a girl, then is a clever. Is it possible and? Is it possible conjunction? You get a wrong meaning. So this is not correct. And in English, but in logic you need to use are. So what you have to use? Pick an object. X is either boy or girl. Then definitely clever. Everybody? So this is what the problem with the predicate logic. People read something and they need to interpret some other way. Everybody? And is very dangerous word. And is very dangerous word. Everyone? Is that clear? And at the same time I'm going to talk about every boy is okay. Let's say every cat is clever and charming, something like that. Now, how do you speak this? Here is there, cat is there, every is there, clever is there, charm is there, and also there. Now you know that for all x, Now every cat we are applying, okay, C of x, okay, सारे C आया, cat of x implies, ये भी clear है, but ये and क्या होगा अभी, ये and क्या होगा, come on, and क्या होगा अभी, r होगा and होगा, अब बताओ, previous and was r, but this and is what, come on जल्दी, ये होगा and ही होगा, क्लियर, ये होगा and ही होगा, ये r नहीं होता, previous one was the object, you can't satisfy both properties, boy and girl. So here be careful where to apply and as r, and understand the interpretation, then you should be careful. I hope you understood the concept. Okay, let's move on. So this is correct, this is correct, and I have a problem now. Now I have a problem. You have written something like this. Understood what you have written? B of x or g of x implies c of x. Yes or no? You know that this is actually same as for all x, comma, b of x or g of x implies c of x. Yes or no? I don't need parenthesis if I use a comma, because comma is evaluated last. So what happens here? What happens here? B of x or g of x is going to be applied before implication. Already for all x is applied together, and then implication is applied next, then comma applied last. So be careful when you don't use the parenthesis. Actually these two are together, because R, the disjunction, has more precedence than implication. Everyone, in the exam they are given this kind of notation, their comma people were not able to interpret properly. Okay, let's move. And not every student is clever. See, I am not good in English, then don't try to interpret. Even you are not good in English, please don't interpret it, because you get a wrong meaning. So we have a technique to interpret properly. Not we apply, and we will separate this statement completely. That is, every student is clever. पता है ना, every student is clever. How to write it? Not of every student is clever. You already know that. What is it? For all x, s of x implies c of x. है तो है ना? You can simply write not for all x, s of x implies c of x. You can simply write. You can delete the parenthesis also. One parenthesis. Right? But this can be written many other ways. How? This not I can apply inside. How many of you know not for all means keep there exist? Not there exist means keep for all. And not you apply for, and or, they are going to switch. ये क्वेश्चन इतने देर के बाद कामा होना चाहिए ना रिप्रेजेंटेशन. इफ द कामा इज नॉट देयर, वो अलग मीनिंग बनता है ना. फॉर ऑल एक्स बी ऑफ एक्स आर जी ऑफ एक्स, ये इस तरफ जाता, ये फ्री बन जाता है ना. x is not applicable for now g of x. This x is only applicable to b. It's not applicable to g. समझ लेना, because for all x has a more precedence, right? Come on. Don't delete that comma. ऋषभ, इंटरप्रेट किया ना. अरे for all x comma b of x or c of x, what do you get? For all x b of x or c of x together. But when you don't have a comma, you know it. Who has more precedence? Quantifiers. So it goes to this side now. It's x is a free here. Everybody, then this is interpreted as for all x b of x or c of x. वो अलग मीनिंग होता है, ठीक है. Now not I can apply inside, not you can apply to, okay, let me write again the same thing. Not for all x s of x to c of x, and not you can apply to this one. Okay, wait. Implication I will delete first. Implication first. I can write not s of x or c of x, है ना. कि implication में not easy नहीं होता अप्लाई करना. चलो अब अप्लाई कर लेते हैं. Not for all, not इसको, and not apply for disjunction, apply for c of x. क्या होगा? Not for all there exist होता. Not of s of x. Not apply for disjunction, conjunction. Not apply for c of x, not c of x. Everyone? So you can say this is nothing but some student is not clever. English में दोनों वर्ड सेम है. Not every student is clever. It means some student is not clever. If you know very well in English, you can directly interpret this also. Everyone? Clear? Okay, now none of students is clever or none of students are clever, singular or plural, use properly. No one is clever. Here you are going to play different role. Here none, I'm writing, guys, look at, it's not easy to interpret. Those who are not able to interpret in English, then at least you should remember my concept in maths. None of students is clever. It means just do something. None is not, you apply and open the parenthesis and close it, and some of students is clever. Can you do that? This is very, very important. It's not that easy like not every student was so easy, but none of students is not at all easy. I am saying it's not at all easy for beginners. I understand how to interpret. And not of some students is clever, it's going to be none of students is clever. And I am going to get English meaning later on. Then apply not some of students. मतलब some student is clever. क्या लिखोगे? What will you write? Quick. You know how to write it. There exists x, s of x, and we will write. You know that some. Correct? You can simply write not there exists x, s of x, and c of x. But you know you can send the negation inside. So what will happen? Not you apply here, not you apply here, apply to and, apply to c. Then what happens? Not there exists will become for all, and not s of x or not c of x. And even this you can convert to implication. How? This is not p, matlab p implies q. S of x implies not c of x. इसका मतलब every student is not clever. Every student is not clever. This is another equivalent statement in English. Everybody, not that some student is clever is same as every student is not clever. So none you divide into two words, not and some. Then apply similar to the not every student is clever, but you get the answer properly. And I hope you understood what I am trying to speak, and this is really important how to apply this none. The no one is clever also same. No, make it as not. One, make it as some. Everybody? How can you write sum is all? Yeah. Some student is clever, all student is clever, both are different, right? No, you can't do that. None means not some. Remember that. None means it cannot satisfy the sum. How can you write all? यार ऋषभ समझ के लिखो यार. कुछ भी all sum all होगा तो दोनों इतना पढ़ना क्या जरूरत है? For all there exists पढ़ना जरूरत क्या है यार? Is it important to study if all sum both are same? Then is this predicate logic is important now? Quantifiers important now? है ना? तो है ना? But all sum, what are you trying to speak? That's a different word. That's a different word. That what we are speaking is something like this. Sorry guys, something is going to happen. All are clever means, it means some are definitely clever. ये कर सकते हैं आप. ये English lines में this can prove this one, but ये word same नहीं है. All can be some, but some need not be all. ये बिल्कुल अलग स्टेटमेंट है. इसको कभी मत करना, है ना. यहां पर कर सकते हैं यार. प्रेडिकेट लॉजिक में नहीं रिप्लेस नहीं कर सकता. हमको इक्वलेंट चाहिए ना. इक्वलेंट में नहीं होता. दे आर नॉट इक्वलेंट, बट इंप्लीकेशन में होता. ऑल इज सम, बट ऑल नॉट इक्वल. ऑल नॉट इक्वलेंट टू सम. ये समझ लो बात. ऑल इंप्लीकेशन होता, बाय इंप्लीकेशन नहीं होता. चलो समझ लो. This is different concept completely. And you are going here and then, and I'll be back. I think this slide's not working. Okay. I hope you understood enough. Students is clever. And if anything is there, please study yourself. I want to explain many, but I will take definitely special class on this predicate logic soon, and try to find out equivalence classes, and they are equivalent to what? If there is anything equivalent, right? And try for implication if possible from somebody. Try from implications. Is it possible to implicate with somebody else? And nested quantifiers and all these things definitely I will cover in not much important, but I will definitely cover in a practice session. Aditya, I don't know Aditya really. I have to study. यार मैं पढ़ाया नहीं पढ़ाया इनको. ये अभी उठ के आता है और फिर डाउट पूछता है यार. इनको डिफरेंस बताओ यार. ये डिफरेंस क्या है? Here domain can be any, but here domain demanding at least one object that should satisfy. अरे ये मैं नहीं पढ़ा सकता हूँ अभी. आप रिवाइंड कर लो वीडियो को. या पीडीएफ दे देता हूँ आशीष. या थैंक यू सो मच फॉर ज्वाइनिंग टुडे सेशन. आई होप you understood important concept. There is lot to learn, but I will help you with the practice session. In the practice session, every question will be elaborated. Then definitely I will explain. So tomorrow I am going to start graph theory. I will start graph theory, and I try to cover as best as possible in short time. But there is a lot to learn in every topic, and please take care of everything that you want. And we are always there to help you. And in case if you are going to take the plus subscription, Iconic, and definitely we will be covering everything, and we will be helping you all the time, and we will never be hurry. And that's what you have a plus subscription. When you pay to somebody, and definitely will be get beneficiable. And Iconic, all the benefits of plus, additionally dedicated coach and separate study material, and so many benefits. In case if you want to know the prices for plus, you have many plans. Among them 2 years, you can see 39,600 after applying DEVALIVE, and for Iconic for 2 years you have 66,600. In case if you need any help, we are there always to discuss which plan is best for you. And this is my profile. If you want to attend my classes on Unacademy, either free or any subscription, then you just visit unacademy.com/DEVALIVE. And this is our Telegram channel where we share our material and our links. And please subscribe to this channel. You will get a lot of beneficiable from this channel and use this channel. And we have various YouTube channels which are absolutely free from top educators of Unacademy. Please share with your friends who are from other engineering streams. Let them study from these channels. And thank you so much for joining this session. And tomorrow we will meet at same timings 8:45 for graph theory. Yeah. If you visit my profile, you will find a lot of free classes on Unacademy. Today I have undiscernibility and Turing motion revision on TOC. And also algorithms, DBMS, data structure. So many revision sessions are also there tomorrow and today. So please follow my profile. Yeah, like the button and please share if you enjoy and subscribe, and please use DEVALIVE referral code in case if you want to join Unacademy.